Hi, this is Kleiner Bear. In this video we will make the sun move on its own when we press play. So let's open up our blueprint. We are still in the construction script that we created in the earlier video. Now we will open the event graph, add new, and we'll make a function for the rotation of the sun, because that will make it more neat. I will call that f_rotate sun. That opens automatically the tab for the function. The first thing we need to create is a variable that automatically increases, like the sun handle we had before, to move the sun in the circular motion so that it rises and sets. For that I will create a new variable and I will call that sun rotation position, or sun rot pos, because I don't want to type that much. I want to set this variable, and for that I need another variable, and that is how long should it take in the game for a complete rotation of the sun. So how long should a day in the game be? For testing purposes you might set it to like 24 seconds. Maybe late in the game you want it to be like half an hour, so that would be 1800 seconds. Anyway, it's going to be in seconds. And so we create this variable and call it sun day duration, for example. And by default I'll make that public so I can edit it here in the editor. And by default I will set it to 24, because that might be convenient. Now we need to create a math expression, so right click, type in math, and that will be open brackets 360 divided by Sunday duration, because that tells us 360 is degrees, is a whole circle, and the Sunday duration is of course like 24 seconds. How long does it take? So it's how many degrees per second is the sun supposed to move. So if the Sunday duration is longer, of course it's less degrees per second. That value would go down, so it moves slower. Okay, and then we take this times a variable I call update interval, and that one will be, we will not like execute this every tick, like every frame. If you have the game running at 60 frames per second, you probably don't want to update the sun's position for every frame, because if you have a really long day the sun will barely move from one frame to the next, and that would be a waste of performance. And so we make the update interval, so you can choose how often per second you want to update, like 50 times, 30 times. You will see the longer the day, the less frequent you need to update the sun's position. Okay, so close brackets, that is that. That is angle per time, and then times time, that makes it an angle again. And that angle we add onto the sun rotation position, so that it accumulates on the sun rotation position variable, and that is the angle it needs to move, and that is what we will do. Oh, we need to create that variable first. Call it update interval. Did I create that now? Let's see, that was not in the picture. Let's rename that. Real quick, update interval. And I'll make that public because that's convenient. Click on the math expression, press F2 to rename it, because the whole equation here is like the name of it, and then just click anywhere. It's renamed. Update interval exists already, so that makes it go in here. Now the thing, while the game is running, that variable will accumulate all the values, and we'll add it up, and at some point it will be 360, and then it will keep adding up, and it will be 361, 362, and so forth. It will get really big. We don't need that, so we will add a node that is called whole and remainder. There it is. And what that does is it divides this value by, in our case, we need 360. And you have two outputs. One is the result, like if you would divide 360 by 360, and the result would be 1. If you divide 10 by 360, the result would be 0, because, you know, that's not possible. And then it gives you the remainder. And we will only use the remainder for the sun rotation position, because what this genius trick does is this thing is counting up when we only interested in the remainder. So it's 1 divided by 360, remainder is 1. It's 10, remainder is 10. It's 100 divided by 360, remainder is 100. And then it's 360 divided by 360. The return value, which we do not care about, we don't use that, would be 1 now. And the remainder would be 0. And then it's 310 or 301. It would be. It's never going to reach that value. And divided by 360. The return value would be 1, which we don't care about. And the remainder would still be 1. Like 360, 361, 362 would be 1, 2, 3, return value, we don't care. So what it actually does is it keeps the value of the sun rotation position between 0 and 359. Just counts up, and then 359, instead of going 360, it goes 0. That's what we want. So that is for the circular motion of the sun, which we can also do right now in the editor with the sun handle. That's still southern hemisphere. So this circular motion we've been doing in the editor with sun handle, we can now do with sun rotation position. But before I plug that into the actual sun rotator, like we did in the construction script, first I want to do the whole sun declination thing, so that this as well will be automatically. And for that we need some more variables, like sun year duration. That is obviously how long a year should be, and that will be in days. So for simplicity, I will make the duration of the year according to the Gregorian calendar that we all use today, which has those leap years, and then there's a special rule when there are certain leap years you do not do the leap day, whatever. That makes the duration of the year 365.2425 days. And of course this is a float, so it doesn't actually do that, but it's close enough. That is the magic of float point variables they can only have certain values, and certain values you want to do aren't possible to display. But that's good enough for us. Another thing we need is the variable sun days, and that is just a proxy that tells us which position in the year we have. Like, is it the first day, the second day? But it is a float, so it could be 1.5 days. So that means it's the second day, but it's noon. So the day has already started and half the day is around, just for explanation. So for that one, we create a math expression. Getting confused with the accents here. Math, and that'll be what is it? Update interval divided by Sundays, and we add that, no, divided by Sunday duration, and we add that to sun days. And what that does is you kind of look, this is how much time has been passed since the last update, so we have to add that, but only like the portion of a whole day. So how much of a whole day has passed, that's kind of what you're trying to find out. And so that part you add to the Sundays. So let's drag Sundays onto the execution pin to get a set. And now we have the same problem. It would count up and would really get big, but we only need it to be as big as the sun year duration. So again, right click, type in WHO to get the node division, whole and remainder, plug in the math expression into the dividend, well, you see it. And into the divisor you plug in the sun year duration, because we only need to count it up to that, and then it can be 0 again, because, you know, start the new day, the new year. Okay, so now we got that proxy. And now we will set the sun declination. There it is. And yeah, for that we need a cosine function. We will still use a math expression. So it will be cosine, because it starts like in winter, so it will be the lowest negative number, then it will rise up to the highest value, and from there it will like make a curve and go down again to the lowest, to winter. So it's like a wave, and that is a cosine. Yeah, what we will do is will be sun days plus 10, because the shortest day of the year where the sun declination is this lowest value, northern hemisphere that is, of course, is not January 1st, but it's like December 21st. So we are adding an offset into where we start in this sun declination cycle. So we want to start at January 1st, and then the sun declination, of course, is not at its lowest, but it's a little higher already. So that's why it's plus 10 days. Oh, we need more brackets here. And then we take it times 2 times pi, because that is the length of the cosine function, is 2 pi. And by multiplying the position in the cosine wave by 2 pi, we make the length 1. And then we divide it by sun year duration, and that makes the length of this cosine function the sun year duration. Close that bracket. And the maximum value of the cosine is 1 and the lowest is -1, but we need minus 23.5 and the maximum to be 23.5. So we have to now multiply it by 23.5, actually minus 23.5, because the cosine function always starts at the maximum level, so it would be start at 1. So if we just take it times 23.5, we would start in summer. But we want to start in winter, and so we have to take it times minus 23.5, and I'm going to put that in brackets so we don't get confused. I'm going to press enter, it won't work. I'm going to show you why. So there's an error. Math expression doesn't like this. So what we will have to do is actually, because this whole minus 23.5 doesn't work, and the only workaround I have found is to make it like a subtraction, 0 minus 23.5. And now it's happy. Pi, this, what do you call it, circular constant, whatever, I couldn't find in the math expression what I'm supposed to type in, like math.pi or whatever. It doesn't work. So instead, I'm going to just call it pi. It makes for a pin for a random variable. So the math expression doesn't know what that is. Could be anything. So you could call it X or, you know, grandma, doesn't matter. But now I will right click, type in get pi, which it creates the node get pi, which is pi, of course. And if I plug that in, now we have pi. Pretty easy. So I don't know if these lengthy explanations of what the math does are any help. If not, sorry. So let's compile this. Now we have the variables that should automatically do what we did in the editor before. And now we need to set the sun rotator. Just drag it in, drag a wire, type in set rel, set the relative rotation, that is for the circular motion, and make it neat. Now I drag a wire and type in rotator, gives us rotator from axis and angle. The axis, of course, is the North Pole, that is here, and the angle will be our sun rotation position. And if you notice little jumps in the video, that's where I pause the record and I flip over to my already done day-night cycle, because I don't want to put in any more mistakes. Yeah, now we drag the component for the sun and drag a wire, type in set rel, set the relative location, connect the execution pin, new location, drag a wire, type in, what was it, rotator, rotate vector, that's what we need. The vector, of course, is again only 1000 on the x-axis, y and z are 0. I split the structs pin so I can access the pitch. Here we create a math expression, right click, math, and that is again like in the construction script 270. minus, what was it, latitude minus sun declination. And that we plug into the pitch. Now, what we need to do is, we have this function, but we need to call that function. And so we change to the event graph. And there is the event begin play node. And we drag a wire. And then we type in timer. And there it is, set timer by function name. And the function name, of course, is f underscore rotate sun. And the time that it's called is the update interval. And very important, check looping. So it does that again and again and again. And every update interval. And that is currently default 0, so let's make that 0.02, because that means it gets called 50 times a second. That's a nice value for testing purposes. Later when it all works and you want to have a longer day-night cycle, like half an hour, 2 hours or whatever, you can, set that value higher, so it gets called less frequent. And you save performance. So let's see if anything happens. There you go. If you're wondering why it's stuttering, I think that's not the update interval, that's because I'm rendering the other video while I'm doing this one. So don't worry. It's doing fine. That is that. And now on to the next video.